Hello, we are Seminar 10 Group 3 from BC2402, Designing and Developing Databases. This is our presentation for the final group project on airline chatbots. We will be discussing questions 6 to 10 in order. I am Abhirami, presenting question 6. Alwan will present question 7, Ethan will question 8, Charlene question 9, and Karan will present question 10 and wrap up our presentation. Let's start with question 6. The aim of question 6 was to explore potential correlations between flight duration, length of stay, and passenger preferences, like extra baggage, in-flight meals, and seat selection. So question 6 asks for the ratios of some variables with average flight hour. The column flight hour, as initially specified, was identified as representing the flight's departure time rather than its duration. However, it makes little sense to compare the data with what time the flight departed. The times which flights depart are purely random and would not give any logical correlations or trends. It made more sense to compare the variables with the duration of the flight. Hence, to ensure logical consistency, the column flight duration was used instead. Ratios were calculated for combinations of sail channels, resulting in over 1,000 moves. Each row represented one combination of the respective computed ratios. SQL effectively computed these values, but it lacks inbuilt visualization tools like Python and R, which results in a limited interpretation of the results. So one method we tried for finding the correlations between the values is applying the Pearson formula to compute linear relationships between variables like flight duration, length of stay, and the customer preferences. However, due to the large dataset and absence of visual context, the raw numerical outputs were insufficient for identifying meaningful trends. This highlighted the need for external tools for deeper analysis. Before we look into external methods for visualization, we tried MongoDB first. Although MongoDB could theoretically be used for the first part of the question, which is calculating the ratios, it is less efficient than SQL for tabular data. Calculating averages and ratios require complex aggregation pipelines in MongoDB, which are less intuitive. Furthermore, MongoDB, like SQL, lacks analytical tools for visualizing and interpreting trends, making it equally unsuitable for deriving correlations in this context. On this slide, you'll see the MongoDB query that would give us the ratios and the SQL query. As you can tell, this is in fact less efficient and has less to do for this question. To address the limitations in visualization, the SQL output was exported as CSV files to RStudio. By using ggplot package, correlation plots were made. The plot as shown on the slide shows that there are three significant points that can be taken from this. These are highlighted using the green circles. So it shows that the length of stay and extra baggage have a positive correlation. This suggests that longer trips have a higher demand for additional baggage. There's also positive correlations between using per meal and extra baggage. So this could indicate that passengers on longer trips or those with higher budgets tend to select both of these services. And lastly, there's also a positive correlation between the meal preferences and seat selection. Suggests that passengers are willing to pay for premium services when they have a higher budget, hence they would choose both the meal preference and the seat. These findings demonstrate the importance of visualization tools in uncovering patterns that are otherwise obscured in raw data. SQL was effective for computation, and MongoDB was a bit less efficient, but was still able to get the ratios. However, we still require an external tool like RStudio to find out any meaningful interpretation for these results. Thank you. And now Haran will continue on with question 7.
Okay, so for question 7, we're going to talk about airline seasonality. Okay, then let's first start with the SQL query. For the query part, I first calculate the average rating for several airline services and group them by airline and class. Then filter I filtered the data for June, July, August, and September, which are the season months, using the like operator and label the data as seasonal. And then repeat the steps for non-seasonal months and merge the results using union. And then we can get the table down here. Okay, so let's now take a closer look at the performance of the airline. For Qatar Airways, it demonstrates varying trends across classes regarding seasonal and non-seasonal periods. For economy and first class, average ratings are slightly lower during seasonal periods compared to non-seasonal months. Business class maintains consistent ratings with minimal variation across both periods. And premium economy stands out with exceptional performance, achieving a perfect overall rating of 10 in both periods. And interestingly, Qatar Airways generally experiences higher ratings during non-seasonal months, except for premium economy because it consistently delivers outstanding results regardless of the season. Okay, then for the Singapore Airlines, during seasonal months, ratings for all classes generally show an increase compared to non-seasonal months, reflecting their improved service quality during peak travel periods. And first class stands out with the highest rating among the four classes, achieving the most significant seasonal improvement with a 0.8 points increase, showcasing a strong focus on premium experiences. And economy class also benefits from seasonal enhancement, albeit with the smallest increasement of 0.11 points, indicating relatively stable service. And these patterns highlight the airline's prioritization of service adjustments during high demand periods to meet customer expectations. So now we come to the conclusion. Qatar Airways excels during non-seasonal periods, achieving overall higher scores across most classes, showcasing consistent service quality even during off-peak time. And in contrast, Singapore Airlines demonstrates notable improvement in service quality during seasonal months, particularly in business and first class, reflecting a strategic focus on enhancing the travel experience during peak periods. Now I'll pass on my time.
I will now be answering about the common complaints. We are looking at the top 5 complaints for each airline and each type of traveler. Here are the important columns considered when looking at the top 5 complaints. We used columns that were only verified, as this means that the review from the consumer is true and it's confirmed. After that, we considered overall rating and recommended. And we also considered seat comfort, staff service, food and beverages, in-flight entertainment, value for money. We didn't use these columns in the end because they gave us inconsistencies against each other. As you can see in the below picture, the consumer in the second last row gave an overall rating of 9 but did not recommend the airline. You can see in the third row that a consumer gave staff service and food and beverages a 1 but gave an overall rating of 9 and recommended the airline. We felt that this is a inconsistency and decided not to use it. Therefore, we only use reviews column for finding our top 5 complaints. So we created 12 categories ranging from baggage handling to website issues. We then created multiple words for these categories, such as lost for baggage handling and torn for baggage damage. For website issues, we use words like glitchy or unresponsive. After that, we have these answers. It is clear to see that for Qatar Airways, flight delays and cabin environment were one of the top few things that consumers had complaints for. The rest were pretty similar in having staff behavior and baggage handling in the top 5 as well, along with seat comfort. Next, for Singapore Airlines, flight delays still took the number 1 spot. And now, they also have complaints about baggage damage. Both airlines have a very similar top 6, and then the rest of the rankings, or the rest of the 6 categories, have the same rankings from 7 to 12. We will now be looking at the limitations to answering this question. It is not possible for us to take into account every complaint, as there are 1,579 rows of reviews, which are paragraphs. So we decided to come up with words that can fit into multiple categories. We couldn't use words that are very generic, like bad, because it would be double counting into multiple complaints. Thank you.
For question 9, based on the number of Singapore Airlines passengers over the years, we can see that there was a significant drop in passengers between 2020 and 2022. Hence, we will be using 2020 and 2022 to define the boundaries for pre-COVID and post-COVID respectively. Using the ratings in the data provided, we analyze the change in average ratings using MySQL, which works well for structured data and queries. We found that the average overall rating declined from pre-COVID to post-COVID. This is likely due to the significant fall in ratings under value for money and food and beverages at about 15%. This suggests that customers were mostly dissatisfied with these aspects, which contributed to a lower overall rating. Despite these changes, we also note that the order of ranking for each aspect has been consistent, with value for money and food and beverages being ranked the lowest relative to other aspects even before COVID-19. Additionally, we have also used NoSQL, which gave us greater flexibility and allowed us to analyze unstructured data like customer reviews. We filtered through the titles of all of the reviews to count specific keywords. The keywords include common terms related to flights, such as baggage, service, and delay. The keyword with the highest frequency can be identified as the aspect that customers are most concerned about, reflecting either positive or negative sentiments. From our results, the most popular preferences and complaints have consistently been about service, followed by seats, then food. While the key concerns of passengers remained largely consistent, there were likely shifts in sentiment associated with these concerns, as seen from the decline in overall ratings. This change in sentiment presumably reflects the evolving context of air travel before and after the pandemic, as well as broader operational changes within Singapore Airlines. For the second part of the question, Singapore Airlines' strong performance could have been driven by other external factors. Firstly, there has been strong travel demand in North Asia, with passenger traffic surging 27% in Q3 and recording almost 50% more passengers compared to 2023. Secondly, there was greater pent-up travel demand due to the COVID-19 lockdowns in previous years. Singapore also had multiple high-profile events, such as concerts, which attracted an influx of overseas visitors. Additionally, the growth in e-commerce and the shift to air freight significantly boosted cargo demand, resulting in an increase in revenue for Singapore Airlines. Moreover, Singapore Airlines was also strategic in increasing their flight frequencies to popular destinations during peak seasons, offering the customers greater flexibility, which has helped to attract them. Singapore Airlines has also expanded its network by launching flight services to more regions like Subang and Kertajati. This enabled them to reach out to more customers, which helps in broadening their customer base. Lastly, the implementation of new visa schemes also played a role in Singapore Airlines' strong performance. The mutual visa exemption scheme with countries such as China has made it more convenient to travel between the two countries. The ease of travel would hence lead to higher passenger traffic, allowing Singapore Airlines to perform well. Therefore, these strategic moves, coupled with strong travel and cargo demand, have allowed Singapore Airlines to perform strongly in recent periods.
So, for query 10, let's begin by looking at a recent event that underscores the importance of exceptional customer service during crisis. In May 2024, Singapore Airlines flight SQ321 en route from London to Singapore encountered severe turbulence over Myanmar, resulting in injuries to passengers and crew, including one fatality. While Singapore Airlines promptly provided compensation and assistance, the incident highlights the need for timely, empathetic, and efficient communication during such exceptional circumstances. This presentation explores how a smart chatbot can enhance customer support by addressing critical queries, clarifying safety measures, and guiding passengers through processes like compensation claims. By ensuring responses are accurate, empathetic, and efficient, this innovation not only improves customer satisfaction but also reinforces Singapore Airlines' reputation as a premium airline. To fully appreciate the need for this chatbot, let's look at the business context and challenges associated with such incidents. First, customer sensitivity is a key concern. Turbulence and similar events often cause significant distress to passengers. Mishandling such cases, whether due to delays in responses or insufficient empathy, could lead to dissatisfaction, social media backlash, or even legal challenges. Second, we must consider brand loyalty. A well designed chatbot that proactively addresses customer concerns can strengthen customer trust, particularly during crisis. This aligns with Singapore Airlines' position as a premium airline that ensures that customer expectations are met even in the difficult times. Lastly, from an operations perspective, efficiency is critical. Automating responses to routine queries, such as those about turbulence policies or compensation claims, reduce the burden on human agents. This enables staff to focus on more complex and urgent cases, ensuring better resource allocation while improving service quality. Data plays a pivotal role in building the smart chatbot. We propose using three primary datasets to train the chatbot effectively. Firstly, the airline's review dataset. This dataset allows us to identify common customer concerns related to safety, compensation, and service quality. By performing sentiment analysis on reviews, we can categorize customer feedback into emotional and rational concerns. For instance, analyzing reviews that mention turbulence and safety issues, just like how we did in the query 8, helps us identify the exact pain points of the customers face. Secondly, the customer support dataset. This dataset provides real-life example on how customer service queries are handled. It captures linguistic variations such as formal versus colloquial language, ensuring the chatbot understands the diverse ways customers phrase their concerns. It also provides templates for empathetic responses, ensuring a balance between professionalism and relatability. Lastly, we are thinking of creating a new dataset integrating Singapore Airlines compensation policies ensures that chatbot can provide legally compliant and transparent guidance. By referring real-world examples such as SQ321 incident, the chatbot can offer personalized assistance, ensuring customers feel heard and supported. The proposed chatbot combines advanced features with empathetic design to address customer concerns effectively. Firstly, the intent recognition identifies the purpose behind queries, such as safety concerns or compensation claims, enabling tailored responses. Secondly, safety guidance. It provides clear explanation of safety protocols during incidents, reassuring the passengers. Thirdly, the compensation assistance guides users through eligibility, documentation, and submission process for claims. Lastly, the proactive support offers links to FAQs and resources, reducing the response times and empowering self-service. We want the chatbot design to be ensured that it's empathetic, use phrases like we regret to the inconvenience cost, to show that it's caring and understanding just like in this example. Now let's move on to some more examples. As you can see that in these responses, it needs to be trained with those three essential data sets for getting to know the tone of the query, past incidents on safety, and also the eligibility. Lastly, implementing this chatbot will deliver significant business benefits for Singapore Airlines. Firstly, the customer satisfaction will improve due to quick and empathetic resolutions of concerns. Secondly, the operational costs will be reduced as chatbot automates the repetitive task, allowing human agents to focus on more complex cases. Third, the brand reputation will be strengthened as the chatbot demonstrates Singapore Airlines' commitment to customer care and transparency during disruptions. Lastly, the chatbot ensures compliance with legal and regulatory requirements, minimizing the potential liabilities. By this, we have come to the end of our project presentation. Thank you.